In the last video, I said that binary signals are often the way to go for moving and storing information. Notably though, binary signals are limited in how much information they can get across, since they only have two states each, on and off. There's an easy way to communicate more information using binary signals though, and that's to just add more signals. For each binary signal you add, you double the number of signal combinations you can use to communicate your information, meaning you're able to communicate about double the information. This introduces another problem, though. Not a technical problem as much, but a problem nonetheless. If you have a bunch of binary signals working together to store a piece of complicated data, it's important to have a consistent and reliable way to interpret that data. One way to do this is to use the base 2 counting system, also known as the binary counting system. Before I talk about binary, though, I think it's important that I talk about the number system that you're probably used to, base 10. This is related, just stick with me for a second. In base 10, each digit of a number represents a power of 10, starting with 10 to the 0 on the right and going up 1 for each digit. In each of these digits, you can have one of 10 characters representing different values. For the total value of the number, you can multiply the value in each digit by the power of 10 each digit represents, and add all of those up. To count up, all you do is change the rightmost character by 1, and if you run out of characters, you reset that digit and increment the next digit by 1. With this in mind, my explanation of binary should make a little more sense. In binary, or base 2, each digit of a number represents a power of 2, starting with 2 to the 0 on the right and going up by 1 for each digit. In each of those digits, you can have one of 2 characters representing different values. For the total value of the number, you can multiply the value in each digit by the power of 2 each digit represents, and add all of those up. To count up, all you do is change the rightmost character by 1, and if you run out of characters, you reset that digit and increment the next digit by 1. With everything laid out like this, hopefully you can see the similarities. The main difference is the number of characters you have. Decimal gives you access to 10 number characters, 0 through 9, meaning each digit is a new power of 10, while binary gives you access to 2 number characters, 0 and 1, meaning each digit is a new power of 2. The total value thing isn't super useful for decimal, considering this is how people typically represent numbers normally, but using it on a binary number gives you a way to translate from binary to decimal. Using binary like this can even be seen in Minecraft officially without building some huge system to do so. Taking a comparator output from a shelf will give a signal strength that might look weird at first, especially when most other containers give comparator outputs based on how full they are. With a careful eye, though, you can see that these outputs are based on binary. You could also tell this based on the fact that I'm bringing it up in this video. Any slots with items in them, no matter the stack size, counts as a 1, and any empty slots will count as a 0. Something a little odd is that the digits of this binary are reversed with 2 to the 0 on the left and 2 to the 2 on the right, but I'm guessing it's just like this to make it easier to use in conjunction with hoppers, so you can like store signal strengths and stuff. Now, I just said a lot of stuff, so let's put it in action and kind of lock it in your head a little with an example. Let's say we have a number attached to a sugarcane farm to see how many times it's been triggered. Why? Why not? Having useless statistics like this can be fun. Now, assuming the counter hasn't overflown yet, and it started at 0, if it's currently showing this, and the on lamps represents year ones, how many times has the farm triggered? I'll give you a second to think about it. Alright, got your guess? The answer would be 22. You can get this by multiplying each digit by their respective powers of 2, then adding them up like I mentioned earlier. In this case, it would be 0 times 1, or 2 to the 0, 1 times 2, 1 times 4, 0 times 8, 1 times 16, and 0 times 32, all added up, which, if you work it out, would be 22. Now, let's give an example going the other way, too. Let's say you want to send the number 43 along this set of wires. Assuming the ones digit is shown on the right, like normal, which wires would you power? Again, take some time, pause the video if you need to. Got an answer ready? To send the number 43, you would power these wires. I haven't explained how to get to this point yet, so don't feel bad if you didn't get it. To actually get to an answer, you could count up the powers of 2 until you get one bigger than your number, go back 1, turn on the corresponding bit, and subtract that power of 2 from your target number. Then you can repeat this process until you have a full binary number and your target has been reduced to ashes. Looking back at our example, we can calculate the powers of 2 up to 64, or 2 to the 6th, go back 1 to 32, turn on the right bit, and calculate 43 minus 32. Now we do that 3 more times and get our final answer. I could keep talking about binary, but the video is probably long enough by this point, so I'll cut it here. If you want to hear more, like how to represent negative numbers or some different ways to interpret a binary number signal, let me know in the comments. While on the topic of future videos, I'm probably going to talk about Minecraft rocks pretty soon. Might be the video after next one, might be later, but whatever. I would do it as my next video, but my video on different ways to store numbers and like memory stuff got more attention than I'm used to, so I want to make it clear to all the new people that I'm not planning on moving away from Redstone. Thanks for that, by the way. That was a pretty fun surprise. As for what my next video will be, that can be left as a surprise. I'm definitely not saying that because I don't know what I'm doing, but until then, though, have fun doing some Redstone.